Class, we're going to go over 5.2, bisectors and triangles. So we're going to use properties of perpendicular bisectors and angle bisectors. So perpendicular bisector means we have a 90-degree perpendicular is 90 degrees. So we're going to talk about when we have a bisector, so something that cuts it in half and meets at 90 degrees, and what our properties are for that. And then we're going to look at an angle bisector. An angle, again, bisector means we're going to have a line that cuts the angle into two equal parts and see what properties we have from there. So we'll start out with the first part. Hold on one second. There we go. Okay. So first property as we go through is a perpendicular bisector. So we have a perpendicular bisector. So CD, okay, bisects this line AB. So first of all, we have 90 degree, that means perpendicular. Bisect means those two parts are equal. So if we have a perpendicular bisector, that means the distance is equal. So anywhere these endpoints are going to be equal distance from this line. So wherever they meet, from here to here, doesn't matter, they'll be equal. So that's what we're saying right there. So take the time, write it down. So let's go ahead and look at what this means, what type of stuff you'll be using with it. So then we'd say the converse. So we first state if we have a perpendicular bisector, the endpoints are equal distance. If the endpoints are equal distance, then we have a perpendicular bisector. So we come here, CA and DB, that's what we want to find. Again, C to A, D to B, D to B. So what we have is we have a perpendicular bisector, 90 degrees, bisects, so we know the endpoints are equal distance. B to C is equal to A to C. Since they're equal, then we know that A to C is 5. We also know the endpoints are equal here as well. So A to D is equal to D to B. So there's our answer. CA would be 5 and DB would be 6. So we come here, solve for the variable. Well, again, what do we have? We have a perpendicular bisector, so we know the distance from the endpoints are equal. So we'd say 5x is equal to 2x plus 9. Subtract, so we know that they're equal, so we'd subtract 2x to get 3x, divide by 3, and x equals 3. If they said find out what AD is, take 3, plug it in, and it would be 15. Okay, now we have AD is the bisector. So here's our next property. So if we have a bisector, okay, it means it cuts it in half. Then it is equal distance. The bisector of an angle, then the point is equal distance from the sides of an angle. Just point out, so this distance from here down, here down, here down, it's always going to be the same. We want to meet at a 90 degree. This angle has to be the same. So if that angle weren't the same, then we wouldn't say that they're equal. So as long as that angle is the same, then that distance, so from this distance from D to B is the same as D to C. And again, we'd say the converse of that. If that distance is the same, then we know that it bisects the angle. So that part would equal that part. So these are two properties. So again, we'll go ahead and look at this. We have an angle bisector right here. We know the parts are equal. Therefore, the distance is the same. So we could say 5x is equal to 2x plus 24. Go ahead and subtract 2x, divide by 3, and then equals 8. Now, we want to find what FD is, not solve for x. F to D is from here over. So we take 8 and plug it in for x. So we go 2 times 8 is 16. 16 plus 24 is 40. Another one, very similar to it. Now we know that the distance is the same. So if the distance is the same, then we know that this line, EK, bisects it. So we know these angles are equal. So we'd say 2x equals x plus 20. Solve for x, x is equal to 20. One thing we want to point out, we want to find what is angle KEH. Angle KEH is this angle right here, or KEH down here, this angle here. So we'd say 20 goes in for x, so 20 plus 20 is 40. So that angle KEH is 40 degrees. So those are two properties for today that we've gone over. If we have a perpendicular bisector of a line segment, then we know the endpoints are equal distance. If we have an angle bisector, then we know the distance is the same from either side of the angle to that angle bisector.